Hello, chemistry students. Welcome back. Today we're going to start to talk about matter. It's in our second unit, first concept. Let's share the screen. So these slides are posted for you on your Google Classroom, and there'll be a small assignment when we're done. But the big idea is that everything in the universe is composed of atoms, and special combinations of atoms called molecules help us understand the property of matter. So your objective today is to be able to differentiate between a substance and a mixture. And there's some key vocabulary we'll be working with: element, compound, and formula. So I want you to take your notes in your spiral notebook, add the vocabulary to the vocabulary section, and these notes are posted so you get to go back and update anything that you want to add to. So, as we talked about before, what is matter? Matter is anything that takes up space and has mass. Matter is either a substance or a mixture. Let's repeat that. Matter is either a substance or a mixture of substances. And so a substance is all the particles in matter that are identical in a fixed composition, but a mixture is two or more substances that are physically combined, and they'll have a variable combination or composition. So if we take a look at this flow chart, we start at the top with the big idea of matter. And you can put this flow chart in your notebook. On the left-hand side, we look at a pure substance. A pure substance is an individual element like sodium or copper or oxygen. And then a compound is where those elements combine with each other to form a new substance. So for example, table salt, stuff that you put on your burgers and on your French fries. That's a combination of sodium and chlorine. Sodium by itself is Na, chlorine Cl. When they combine, they create a chemical reaction and they make a new compound known as NaCl or table salt. On a mixture, mixtures can either be homogeneous mixtures, mixtures that are evenly mixed together, or you can have a heterogeneous mixture where you can actually see the different items that are in there. And we're going to look at those in greater detail. So we've got the two types of substances. Let's go back to our flow chart here. We have matter, substance, and within a substance, we start off with an element. An element is the simplest form of matter which more complex substances are made. And each of those elements are listed on the periodic table of elements. All atoms that make up an element are alike. So for example, helium. Helium is a noble gas, but all of the atoms of helium are alike. If we look at elements from a molecular standpoint, elements can exist like helium, argon, and neon that are stable as individual atoms. We call those the noble gases. They're in group 18 on your periodic table. But like oxygen, nitrogen, and hydrogen, they're only stable as two atoms in the cells bonded together. We're going to look more at bonding a little bit later. But the oxygen element by itself is unstable, so it bonds to itself as another atom of oxygen, forming O2, and that's the oxygen that we breathe. Nitrogen can form a molecule, a nitrogen molecule, N2. And the same thing with helium, H2. I'm sorry, hydrogen, H2. So elements can exist individually, and elements can exist as molecules. Then we have two types of substances. We looked at the element, and now let's look at the compound. A compound is two or more elements that are chemically combined in a fixed proportion. But they can be broken down, but only by chemical reactions. Most compounds, once they are formed, can only be broken back down by another chemical reaction. So for example, we talked about salt. It's sodium, which is a soft metal, and chlorine, which is a liquid. When those two come together, a chemical reaction occurs, and they now become salt. To break them apart would require an enormous chemical reaction to take them apart. But the compound has different properties than that of the elements that make them up. So we talked about the salt for a moment. The sodium is a soft metal that can easily melt at about 200 degrees Kelvin. Chlorine is a liquid, which is already a liquid at room temperature. But if you combine those two together and make NaCl, table salt, it takes almost 1800 degrees Kelvin for that to melt, which is why salt is a great insulator and why we cook with it so much. Water is also a compound. Water is a compound of hydrogen and oxygen, but it takes two hydrogen atoms and one oxygen atom to form water. And what's interesting about water is all of the water that has ever existed on Earth or will ever exist on Earth is already here. Sugar is another compound, and that's a combination of carbon, hydrogen, and oxygen. And you remember that from biology, that sugar was a carbohydrate. But it takes 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms to make the chemical reaction to make sugar. And that happens during photosynthesis. Let's also take a look at the difference between an element and a compound. An element is just one substance in its simplest form. A compound is two or more different elements that have been chemically combined. So, oxygen is an element, covalently bonded element, but oxygen, O2, that we breathe, is one substance. A compound, like carbon dioxide gas, is one carbon and 2 oxygen atoms combined to make carbon dioxide. Now, pure substances is matter that always has exactly the same composition. Table salt and table sugar are 2 examples of pure substances. Once they've been combined, once the elements that are in there that form that substance have been combined, they can be classified into 2 different categories, elements and compounds. So while table salt is a pure substance, it is also a compound. Every sample of a given substance has the same properties because a substance has a fixed uniform composition. Now you may have a lot of it, so you have a lot of those molecules put together. you have a lot of that chemical reaction that formed together. So you have many, many, many of those substances combined. Elements such as aluminum, carbon, and gold are elements that you can see in common objects, such as cans, pencils, rings, jewelry, and mixtures containing iodines can also be used to prevent and treat infections. So each of these are individual elements that you'll find on the periodic table of elements. Gold has an elemental symbol of Au. Aluminum is another metal. It has an elemental symbol of Al. Carbon is C, and iodine is I. But these are each individual elements. Compound is a substance that's made from two or more simpler substances that can be broken down into those simpler substances. A compound always contains two or more elements joined in a fixed proportion. We looked at table salt, NaCl. It's one atom of sodium, one atom of chlorine. Water is two atoms of hydrogen, one atom of oxygen. Caffeine that you find in your coffee is broken down into a chemical compound, and it has carbon, hydrogen, nitrogen, and oxygen. And you remember from biology, those elements were all part of the 6 elements that are necessary for life. But it's how they're mixed together. It's the proportion that's in them that lets them become different substances. So for caffeine, it requires 8 carbon atoms, 10 hydrogen atoms, 4 nitrogen atoms, and 2 oxygen atoms combined to make the substance we know as caffeine. Then there are mixtures. So we've talked about matter and substances, which have elements and compounds. And now we're going to talk about mixtures. And the first mixture is what is known as heterogeneous. Heterogeneous substances in the mixture are not evenly spread out. So when you make salad dressing, it has a combination of oil and some spices and some vinegar and some water. And that is a heterogeneous mixture because over time it can separate. And these different components are easy to see, and they will separate out over time. If you're using oil paint is the pigment or the colorant combined with oil, and over time, those will separate. Your breakfast cereal, those Fruit Loops and Lucky Charms. I like Lucky Charms. That is a heterogeneous mixture. You can see the different variations of what's in that mixture. Your trail mix is a heterogeneous mixture. But if we take a look at that mixture, let's jump down into it from a molecular standpoint. The difference between a homogeneous and a heterogeneous mixture. The heterogeneous mixture could easily separate, but a homogeneous mixture is an even distribution. So we'll always have an even amount of items in it. So for example, salt water. Salt water is a combination of H2O and NaCl. Now, a chemical reaction doesn't happen there, but you take the water and you can add salt to it. The salt will dissolve in the water and it will become evenly mixed. However, if you take that container of water, take it outside, pour some of it on a plastic tray, let the water evaporate, what's going to be left is the salt. So it's a mixture and not a compound. That heterogeneous mixture is an uneven distribution. So all of the items in that mixture are different. And there are different amounts of them in there. They're not evenly distributed. So homogeneous equals even distribution, heterogeneous, uneven distribution. So if we look at these mixtures in a bigger picture, the grains of sand are a heterogeneous mixture of different grains of rocks. And the way sand is made is it's a variety of rocks that have been ground down over the millennia by wind or by water. All of that sand that's at the beach comes from the combination of the water flow and the water pounding on those rocks and on those shells, breaking them up to make all the different tiny grains of sand. The spoon over here that's holding these grains of sand is made of stainless steel, and that's a homogeneous mixture of iron, chromium, and nickel. There's not a chemical reaction that happened there, but it's just an even distribution forming that stainless steel. This is your classifying matter flow chart, and I'd like you to put that into your notes. We start with matter on the top. We move to substance down on the left. You can then have an element or a compound as a substance. And a mixture on the right can either be heterogeneous or homogeneous. On the substance, it's a fixed proportion. It will always be exactly the same. The element is found on the periodic table, and the compound is two or more elements that have been chemically combined through a reaction. And the only way to separate them is to create another chemical reaction. A mixture is physically combined. Hey, chocolate milk is physically combined. And that mixture can either be heterogeneous, where it's different, you can see how it separates, or homogeneous, where the mixture is smooth and it's the same and it all looks the same. So let's review. Matter is anything that takes up space and has mass, and matter is either a substance or a mixture. And what is a substance? A substance is when all the particles of matter are identical in a fixed composition. A mixture is two or more substances physically combined, a variable composition in there. And an element is the simplest form of matter from which more complex substances are made, and each of those elements is listed on the periodic table of elements. All right, we've covered a lot today. What you're going to do is you're going to open up the next tab, and there's a practice assignment on classification of matter. You're going to have this in a form on your Google Doc. All the images are there. It's matching up whether it's a substance or a mixture, an element or a compound, whether it's a homogeneous or a heterogeneous mixture, and you'll have some fun doing that. Well, that's all we have for you today. We'll see you next time. Have a great day.